Hey friend, it's Colin from SonicScholar.com. Today we're in the first video of the Data Structures playlist, where it's all about giving you the right tools for the job to organize your app better, code more productively, and make your apps more efficient. Really quickly, if you consider yourself to be a beginner to intermediate coder, I want to give you 6 things to start doing to be a smarter, more productive developer. These are things that I would tell my younger self if I could travel back in time a decade and a half. Click the link in the description. It's yours for free, just as a way to say thanks for watching this video. All right, let's dive in. All right, so this video will focus on arrays. Now, arrays are the simplest data structures that are essentially comprised of contiguous blocks of fixed size of allocated memory that you can put stuff in. When you make an array, you tell the computer how much memory you want, and then it goes and finds a free chunk of RAM and says, here you go, I've allotted or I've allocated this memory for you to go and do whatever you want with. I like to visualize an array on paper as like a big rectangle full of empty parking spaces that you can put stuff in. You get exactly the number of spaces that you asked for, and you're not allowed to put data outside of the bounds of the array. And in computer science, we like to count from 0, so we give numbers that define the space in the array that we're talking about, starting at 0 and counting upward. So if I had an array of size 3, the parking spaces would be numbered 0, 1, and 2 respectively. And for any array of size n, the last parking spot available to you to access would be n-1. Again, because computer scientists love counting from 0 for good reasons that I can't dive into here. But what happens if you run out of parking spaces in your array and you need more? Can the computer just allocate more spaces on the end of your array? Unfortunately not. The way computer memory works is that it's a shared resource between all the data in your application and other data in other applications running on your machine. Because of that, the computer makes no guarantees that there will be room for more parking spaces on the end of your array. For example, some other part of your application could have allocated memory for a string immediately after your array. It would be bad if you increased the size of the array and overwrote the subsequent memory. In fact, that's a common vector of cybersecurity attacks called buffer overflows or buffer overruns. So where does that leave you? You need more parking spaces, but your array is full and you can't expand it. Well, in this case, you just allocate a new array that's bigger than the old one with presumably enough additional parking spaces that you need. Then you spend n copy operations, where n is the size of your old array, and copy each element from the smaller array into the bigger one. Lastly, the old array isn't being used anymore, so the garbage collector can come along and swallow that memory, freeing it up again. Let's take a look at how this works in C#. Here I've got our array demo, and I'm going to start by allocating an array of size 5. Okay, so it's just a brand new array, and if I look inside of it, it's all zeros. Those are just the default values. Then what I'll do is for the whole length of that array, I'm just going to put the number 42 in each thing. So I'll loop through that and do that quickly, and then I'll print out the contents so that you can see that it does indeed have 42 in all 5 elements of the array. It also prints out the length of the array. Now, I said we couldn't just go in and make the array bigger. We have to make a new array and expand it. So I've got a little function here to do that. I'm gonna hit F11 to step in. We'll just come down here. And here's what we're doing. I'm just taking the input array. We took my array, we passed it in. That's now the input array to this function. And we're gonna make a new array, this temp array, and its length will be twice that of the original. So again, looking at the temp array, everything in here is zeros. Now I said we have to spend n operations, where n is the size of the old array, copying the elements into the new one. So that's what I've got here. I starting at 0, while I is less than 5, length of the input array. Take the value in the new array and set it equal to the value from the old array at I. So we'll do that for 5 times. I'm just going to go down to this line and hit Control F10, which is run to this line. And then we can see here's my temp array. And we go through and print it out. We now have my array has been set to a new instance altogether. It's the 10 length array. It has 42 in positions 0 through 4, and the last 5 positions are still 0. And now we can fill up the rest of the array. And notice how we're starting at index 5 here, right? So I've got int I equals 5, saying I want to start at index 5, which again, because we count at 0, means the 6th position in the array. And I'm going to set those equal to the number 73. Again, I'm not going to step through all that code. I'm just going to go down to the next line, hit this little button here that says run execution to here. Essentially does the same thing as Control F10, only it highlights over other lines. So that's kind of useful. Little bonus tip there for you. Now, if I print out this contents of the array, I can see I have the number 42 in the first 5 elements and 73 in the next 5 elements. Some other little bonus tips here is you can use the array.fill method, and that will just, like the name suggests, fill every element with the object that you pass in. So kind of cool there. Anyway, that's it for arrays. You can see that we can't just expand them. We have to make a new one, copy everything over. So that's important to remember when you're using array as a data structure. Remember, you can grab that guide out of the description in the link below and leave me a comment, leave me a thumbs up or a subscribe if you find content like this helpful. And I'll look forward to seeing you in the next video in the series. Take care.